Hi, my name is Andrea Schumacher. You probably heard from another Schumacher yesterday. I know what you're thinking, Nerd Dynasty, yep, that's us. So today I'm so privileged to be able to come and talk to you a little bit about the integration of Earth and social science. We've heard some great talks on the topic so far. I'm gonna get a little bit into the nitty-gritty as an atmospheric scientist by training and mostly by trade, who started working at the interface of interdisciplinary social work, and just how many things I've learned about working with social data. So just a quick start off, this is one thing that I always hear, and it's worth repeating over and over, I think, is that social science is a really broad umbrella. It's like saying physical sciences or natural sciences. And so, but everybody has this idea of what social science is in their own brain. And so I just wanted to show, this is from actually a NOAA Weather Service training module on social sciences that you can find on their SBES, which is Social, Behavioral, and Economic Sciences website. Just a few of the fields that go into social science. It includes law, political science, psychology, economics, sociology, geography, anthropology. So we have to be careful when we just throw out social science. We're really talking about a whole lot of things. So what is social data? Well, of course, there's lots of options for social data. This is a tiny little snippet of what we could be talking about when we say social data. So purchasing data could be a social data set, social media posts, nursing home locations, et cetera, through things like survey data, targeted information that's taken through social science research. So there's just a lot of variety here, which makes working with data sets really fun. So here are sort of my top 3 considerations at this point in working with social data as an atmospheric scientist, so sort of things I've learned. So first is to be cognizant of the temporal and spatial scales of social data. So they're often, because social research is the study of people, they're often anchored to where the people are and where people are doing things. So instead of having gridded data sets, a lot of time you have data sets that are confined by political boundaries, like counties or even census tracts. So that's something that always is worth considering. The timing of this data and the data collection, it tends to be a little less uniform for a lot of these data sets than some of the Earth system science data sets we might be used to. An example would just be a single survey. These sorts of research projects go on all the time where we do surveys, say post-event. And that kind of data is going to be a lot different. We have to treat it a lot differently than some of the data sets we're used to. And this is the real catch for me, is it's really hard and a lot of times impossible to properly interpolate social data. I think in the weather community, we can get really used to creating the time and spatial scales that we need from our data sets through interpolation, and that is really hard with a lot of social data sets. And like I said, sometimes it's really impossible. So the size of social data sets can vary widely. They can be very small. For example, a data set I've been trying to collect on hurricane evacuation orders. It's a simple little CSV file, easy peasy. But they can also be very large. The US Census, an American Community Survey, collects data throughout the US at the census tract and county level. And these data sets generally are large, although we may still kind of laugh because I know that atmospheric science data sets set a new bar for what large really is. They can be available in all kinds of formats. Sometimes social data is collected through qualitative means, and a lot of time that leaves you with large chunks of text. They could be transcriptions from interviews. So that's really important to sort of think about how you would maybe use that. There are techniques you can use to do more quantitative analyses of things like text, like content analysis, but overall it's really something where you might just find data that's a bunch of text files. Or PDFs, that's even more fun because scraping data off of PDFs is so fun. A lot of this data is available in tabular, like I said, or CSV format. So once again, easy peasy it seems. We'll get into that. And a lot of the data that we've looked at through the previous talks has been available in geospatial data, where you can look at it with ArcGIS or other software formats. And speaking of software, I was always used to using things like Fortran and scripting to work with my data. I know Python. I didn't quite get as good at Python as I should have. But when you're working with social data, a lot of the software that social scientists use tends to be a little bit different flavor. One is R, which is open source software that's actually pretty good. SPSS is good for statistical analyses. It's a little more GUI based. SAS, and then ArcGIS, and the other, like QGIS is another GIS format. And I'm just going to put my little quick note plug here is that I've been using R for all of this. I really find that R it can do both. It can do the atmospheric science data sets, including NetCDFs and even GRIB processing. GRIB is not great, but we've got WGRIB, you can convert it to a NetCDF, you're good. So you can work with a lot of the atmospheric science and earth sciences data sets in R, and also work with some of these other data sets like SPSS files, which have a lot of labeling, and they have a lot of metadata you usually want to preserve when you pull those data into certain programs. So I highly recommend R if you're looking at working with 2 or more data sets from the different fields. And lastly, I'll just mention sensitivity. Came up in the last talk with webcams. When you're collecting data about people, we often need to be careful to be ethical and protect people's privacy. And so a lot of research has to go through an institutional review board before you can even collect the data. And the IRB is going to determine what you can and can't do with that data. And a lot of time, social data just can't be shared openly, even after the end of the research. So this is something where you just have to be, you might think, oh, I know there's this, this data set is definitely out there, but there may be really good reasons you can't use it. So, and I just wanted to point out one repository that's becoming more common. It's called Design Safe, and that is a data set where researchers can post not just their data, but also the metrics they use, like their surveys. And so that's a really nice place to go. The data, there's a lot of steps to go through to post to Design Safe, so it's a really good space. So I'm just going to sort of go through this quickly. I just wanted to show one example, and I thought of what's the easiest example of social data, and really the social vulnerability index was the first thing that came to mind, because it's generally, it's collected by the CDC, and it uses 16 US Census variables to help local officials identify communities that may need support before, during, and after disasters. And whereas I don't usually use the index itself, I don't like using indices I didn't make myself. A lot of the input data you can see here about socioeconomic status and household characteristics can be really useful when you're doing research and want to look at some of those overlaying weather and maybe certain vulnerabilities like high winds and mobile homes. So just to sort of look at those little details of this data set, available at census tracts and county level, the input data is continuously collected and it's updated every 2 years. The data formats available are CSV, which I don't recommend. It's a pretty big data set, and shapefiles. And sensitivity isn't really an issue with this data because there's no personal identifiers collected, and it's provided in an aggregate sense over census tracts and counties. So today I really want to focus on giving you an example of working with social data collected from surveys. This is a project that I've been working on for the past 3 years. So generally, here's the outline of the project. It's called Weight the Forecast Change. It's longitudinal panel surveys of the public. And the idea here was that we in the weather community often have a lot of questions when a hurricane strikes that have to do with people. So what hurricane forecast information are people getting and using? What are people thinking about the risks? What are people doing in response to these risks and perceptions? Do people update as the hurricane risks evolve, or do they anchor on a single early piece of information? That's been a big one in the Weather Service. And what can we do to help people better understand their risks and protect themselves? And so the idea here was to address these questions, we really needed something that we call longitudinal data. And we went a little bit further and looked at longitudinal panel data. So the longitudinal piece is through time. And so we collected surveys. We used the same survey instrument 3 times prior to a hurricane landfall within a 5-day period. So we would survey at roughly 5 days ahead of time before landfall, 3, and then 1. And we surveyed the same people these 3 times, so we could look at how all of these factors were evolving with time prior to hurricane landfall. And this is just a little quick schematic of the timing of when those surveys happened. And then we did do a post-storm survey as well. So this was a web-based, English-only survey with participants from the survey company YouGov. This is not ideal, but it did get us the number of responses we needed quickly, because we needed to do this 1, 2, 3 back to back. So it did allow us to field 3 surveys, and we were able to survey the same people every wave. So a piece of this, I'm actually going to go back here and just show you. So all of our survey data was collected on the zip code level. So people self-reported what zip code they were in. So that's just to give you an idea of the spatial scales we're working with. So we wanted to look, so we're asking people a lot of questions about their risk perception and what risk information they're receiving. And we wanted to also be able to know what risk information was being provided at that time by the National Weather Service specifically. The idea being that we could sort of look at matching up intentions versus the idealized state of what we wanted people to hear, to interpret, versus what people reported that they did. So we went and got a bunch of products. I've worked with hurricane data for a long time, and so I was pretty comfortable working with things like the cone of uncertainty, the wind speed probabilities, hurricane watch and warning data. Those are all supplied in different formats. We also took some of the individual hazards and looked at some of those products, like watches and warnings for flooding, some of the longer range products like the excessive rainfall outlooks, and also storm surge watches and warnings, and a couple other with tornadoes watches and warnings, and then evacuation orders, which I've chosen not to talk about today, but since we're making wish lists, if somebody wants to help me collect evacuation orders ever, we've started the process. It would be really, really helpful, I think, to the community. So just example number 1 of sort of working with these data sets together. And my first quick note is working with zip codes. So a zip code is a number, it's not a location. We needed to determine a spatial location based on the zip codes that people were reporting. And the easiest and most commonly used method that we found in social science was using ZCTAs, which are zip code tabulation areas. And it is worth noting, though, that ZCTAs are based on mail delivery routes. So they're funny shapes sometimes and a little bit wonky, and not all zip codes have a ZCTA. For instance, like PO boxes. You're not going to have an actual area. It might just be the post office, I guess. So the US Census Bureau provides what they call tiger shapefiles or line shapefiles for ZCTAs and other types of political boundaries like counties, states, school districts. I have some listed here. And from those ZCTAs, we could assign each person who responded to either a point, which would be sort of some sort of center point we fixed for the ZCTA area, or to be the polygon of the ZCTA area, which was provided. So if you're ever working with zip code data, I would highly recommend looking at this, the Census Bureau Tiger data set. Most software packages have packages already built in where you can pull it in easily. I know in R, you literally just install the Tigris package, and then everything's there for you. So what we chose to do for this study was to use the polygon data. So this is sort of research question 1. We wanted to compare survey responses of people that were in areas that had higher risk of actually being impacted by tropical cyclone hazards versus those that weren't. And we were calling this metric exposure. And so we decided to define exposure in terms of the risk messaging that was involved with our cases. In this case, I'll be talking about Hurricane Ian in 2022, which was the last case that we surveyed for. And so we looked at several different weather service products, including the cone of uncertainty, watches and warnings for surge and hurricane winds, tropical cyclone wind speed probabilities, and whether people were under an evacuation order or not. Here's that dream data set. So I'm just going to show one quick example. So say we're looking at the wind speed probabilities. It's worth mentioning that these are available in both grid format and also as shapefiles. So say we're using the shapefiles at this point and we've sort of reduced them down to just the area where the wind speed probabilities are 30% or higher. So we want to find out if the ZCTA is in our exposed region or not. So when it's all the way in, the 30%, easy, right? When it's all the way out, it's really easy. But what about when it is partially in, partially out? So this is where we needed to go back to, and I'm sort of framing this a little differently, but we need to go back to our story. So what are we looking at? Why are we looking at this intersection? What does it mean? So for our research, we're interested in identifying respondents that could reasonably believe that they had a chance of experiencing impacts, because that would potentially affect how they perceive and respond to risk. So individual interpretation of risk messaging is complex, nuanced, and associated with a lot of uncertainty. But generally speaking, for this particular quest, we'll say, we would prefer to overclassify our exposed cases versus underclassify. So in this case, we decided that any overlap of the 30% or higher wind speed probabilities in our zip code area would be considered exposed spatially. So what about temporal matching? Well, wind speed probabilities are updated every 6 hours. And so you could start maybe overlapped a little bit, and then 6 hours later it could have shifted and that zip code is out of the wind speed probabilities again. Okay, well, if we want to be strict, we could just say, nope, it's not, if our analysis time is that plus 6 hours time, we could be like, nope, not inside the zip code. But let's think about people. Let's go back to our research questions again. Are people going to necessarily be watching everything like this and updating that quickly? And we decided, no, that's definitely a bad assumption to make. So we decided once again that we would prefer to overclassify our exposed group rather than underclassify. And so if a respondent's ZCTA intersected with the risk message area anytime within the past 12 hours, we considered that zip code exposed. And once again, how did we make those decisions? This is once again something where I think it's understated how many decisions have to be made when you're working with different data sets and combining them. And this is really where sensitivity analysis are crucial. We are in the process of going back and trying to understand what if we made a slightly different decision, especially with people. We don't have hard numbers. How long does a person need to catch up on messaging? You can't go look that up. So it's really, really important that you make the best decisions you can, but you also sort of do the work afterwards to make sure that your decisions aren't affecting your outcomes in a way that you wouldn't hope for, you wouldn't expect. So this is just a quick, very ugly picture of what our exposed versus not exposed look like. I call this the like ketchup and mustard sort of plot. It's sort of like a carnival, but it does show all of the different things that went into our exposure versus not. And the yellow zip codes are the ones that were considered exposed at the 3 different waves that we did surveys, and the black were not. So, okay, so our next sort of, the next example I'm going to show is a little more tricky. So we wanted to look at perceived versus actual exposure to risk messaging. So we had a survey question that asked, please indicate whether or not your home currently is in each of the following areas. And so we can start here with the cone of uncertainty. Hopefully we all know what that looks like. Big old cone, literally. It's actually the track uncertainty cone. I apologize for calling it the cone of uncertainty. It's a throwback. So we did some analyses just to see. We were really interested. So these are plots of all of the people who were in the cone of uncertainty based on our meteorological diagnosis of the cone spatial scales, but the people in red were people who said no, they weren't. So this is really interesting in terms of who is actually being warned for something, but they're saying that they're not, reporting that they are not. And so we sort of looked at the spatial disparity of where those no's were, and they're kind of spread out all over, and we knew at this time that the cone encompassed that whole area. And so we weren't really too concerned with the fact that we probably were overcounting people who maybe weren't actually in the cone if they were in another part of the zip code, but they were close enough that it seemed okay. The problem was when we went to storm surge watches and warnings, which are much more precise. So you might just go, okay, we're going to use our little intersection method, and we're going to count how many people were in storm surge watches and warnings that didn't know it. And you go, ooh, there's a bunch of people in wave 3. That's not good. That's a bummer. But when you start looking at where those people are, you can start seeing that, there's a lot of places in there where I would be pretty sure I'm not in a storm surge watch or warning if I were in that zip code. So can we really trust this analysis? And so here I just have the storm surge watches and warnings in red, and in yellow I have one example of a really badly oriented for our purposes zip code. And you can see that there's just a tiny little bit of the zip code that was in the storm surge watch and warning, and a huge area that was not. And you could actually be up to 20 miles away from the warning if you're in this zip code. So this probably seems kind of obvious, but I think that I'm hoping that this sort of drives home the fact that there's no decision that should go unscrutinized when you're combining social and atmospheric data, or atmospheric and atmospheric data even. I just think that sometimes we get a little complacent because we get used to working with certain data sets, and then we have to kind of sort of put on the brakes when we pull in these new ones. So we're kind of saying, no, I don't think we can, with the data we have, I don't think we can answer this question the way we would like to. I mean, technically, yes, we could consider, try to finagle, but ultimately we're not going to be happy not knowing exactly where people are in these zip codes. So maybe in the future, since we can't go back in time, we can collect spatial data differently from our respondents, like a lat lon that's been shifted a little bit. That's sometimes used to help keep things anonymous, but also maybe give us a little more precision on that. So wrapping up, here's sort of the best practices from what I've learned, which I'm certainly not an expert, but I'm happy you're letting me share it with you. It's hard learned, is you really need to know what your research questions are. You need to go back to your research questions constantly. The way you integrate your social and earth science data will depend on what questions you're trying to answer, and that may change question to question. Like, we have a whole survey of questions, and every question we need to consider, what is this question asking? How do we create these integrated data sets so that we can actually do the interdisciplinary analyses to get our answers? So know your data inside and out, and this is where I'm sort of taking the story the story theme a little bit, is know your spatial and temporal scales, your data formats, and your strengths and weaknesses and limitations of your data. And document every step. That's something I didn't really talk about, but that's another great thing with R. R is scriptable, and so the way I have this set up now is, you have to do a lot of cleaning with social data and QC. A lot of time you have to recode variables from one value into another to work with them. Every single step I took is in a script so that you can start with the first piece of data and get the final data set every time. So this is something that I think is underused in social science research sometimes, is that because there's a lot of great software where you sit on the GUI and sort of make your changes. And there are ways to save that. Like with SPSS, you can save what's called syntax, which is what you've done, but you kind of have to do everything cleanly the first time, right? Or you're saving a whole bunch of garbage of like, oops, go back, reload. So I highly recommend taking that approach that you've probably used for other really large data sets and applying that to social as well. And really just know the whole story. Know the whole story of your data sets, know the whole story of your research. And with that, I'll just thank you so much and thank my colleagues. We're working on it's a pretty large research team there that spans disciplines and also universities, and so this is something where it's been a long road of learning a lot from everyone here, so thanks.
Fantastic talk. I loved your highlight of reproducibility, especially since we're all trying to develop stories to tell with our data this week. Maybe take some notes about documenting your workflow during today's session.
You will not regret it.
We do have time for a couple of questions from the room or from online.
I had a curiosity question. So for the study that you were doing, is there a reason that you chose to categorize the data with zip code instead of, say, county?
Well, we wanted it to be as granular as possible. So we wanted the most specific we could get, and zip code was one of the the most localized metrics we were allowed to use and also keep it anonymous, so, which is a big part of getting participation. So we're hoping that there are ways to get it even more, because obviously zip codes, we ran into problems with that not being enough, especially depending on where you are. Some zip codes are tiny, and that's great, you know, but some of them are huge. So yeah, it was really just what was available. So.
Yeah, just another point of curiosity. I was wondering how exposure to the, I guess, getting closer to the storm impacts did participants become more likely to drop out of the study as the storm approached?
So yes, we haven't looked at that specifically, but my feeling is yes. But we also are doing a lot of our analyses, we're only using people who responded to all 3 waves. That is problematic because the people we're losing might be the most interesting. So we did do some experimental methodologies where we didn't, we allowed people to come back for, you know, wave 3 or wave 4, which was post-storm. And we're still looking at ways to analyze that. But that's a really good point, and I think that's such a hard issue when you're studying natural disasters, is that the people that you really want to hear from are pretty busy. So, yeah.
Do we have any questions online? All right, let's thank Andrea again.